So let's start. The next session is Macros Are Dead. What now? Please welcome Remi.
Hello! Konbanwa! So I'm Remi. I maintain a bunch of packages like Riverbot, Provider, Freeze, Hooks, in case you didn't know. So today I want to talk to you about macros, not necessarily my package instead, but more about Dart Fissure. But before that, I have a few questions. So here, who used any of my packages before? Oh wow, lots of people. and who dislikes them? To be funny. Aha! Boo! And yes? No, nobody? Come on. Wow, not fun. Okay, and let's go next. Oh, sorry. Double click. So, in case you didn't know, earlier I released a preview about the Trumpoto for Riverpod. The actual stable release is probably going to be coming in a few weeks. It's just missing a couple of documentation stuff and one or two bug fixes. But the migration guide and change logs are available, and a few docs changes are already available, so you can visit them at those sites. I won't cover the full 3.0 changes right now. It's not really the topic, but for your information, there we go. So what we want to talk about today exactly instead is, in case you didn't know, for a few years the Dart team has been working on a feature called macros, and recently, I think it was January or February, something around there, they announced that they cancelled this feature, even though it was highly requested. I won't necessarily cover why it was cancelled. I would suggest you to read the official blog. The long story short is that it was a bit too complex. So what we will talk about instead is more about what we're macros trying to solve exactly, and what the future for the ecosystem is instead. Because now that we don't have macros, we'll still need to solve these problems. It's not like they disappeared. Okay, so first, why macros? Oh, I guess I wanted to ask you the question about why, but I guess I showed it. Yeah, so macros, the main reason why we have macros, why they were worked on, is for data classes and like JSON decoding, stuff like that. That was the main goal behind it. Basically, a short explanation of the problem is, say you were to want to write a reusable function to like log an object in a pretty way. So like you could imagine a two-pretty string function which can take any object as parameter and render it like this with all the values. The thing is, in Dart, you could define the prototypes of the function. You could maybe start to print the type of the object, but then if you want to print the properties, you wouldn't be able to do that, because with the way Dart works, you wouldn't have access to the list of possible properties of an object. There is no way to do that in Dart due to the type system. And so usually, for those kind of problems, we rely on something called metaprogramming. Metaprogramming, it's the act of basically, as you can see, looking at yourself in the mirror. So basically it's a type which is able to view itself, information about itself, like what are my properties, what is my name, what are my subclasses, stuff like that. Generally, there are two main ways of doing metaprogramming. Languages tend to pick one or the other or both. So one of them is called reflection or mirroring. We used to have this in Dart. It was called Dart Mirror. Basically, mirroring is the idea of programmatically exposing this list of like the keys of an object. So for example, this is JavaScript code, and you could write object.keys, pass any random object, and you could have access to all the properties of an object. Then you can log every single one of them, and stuff like that. Here would be kind of like a pseudocode for Dart equivalent. I forgot the exact syntax with Dart Mirror, so I just winged it. But you could you used to be able to call something, a function called reflect, pass it an object, it would return metadata about the type, and then you would be able to iterate over the various properties and stuff like that. So this is very nice, but the thing is, everything has pros and cons, as usual. So the pros is mirroring is really simple. Like a lot of, for example, JavaScript developers tend to use mirroring in their day-to-day job without realizing it. The problem is it can slow down the app quite a bit because it adds extra overhead over how to iterate over properties and stuff like that. Instead of a simple, highly optimizable read access to a property, you have to go through extra steps to read objects. It also tends to significantly increase the bundle size of your applications, in part because you can't really tree shake your application anymore. Because like tree shaking, in case you don't know, is basically when you deploy your application, when you build your application, the compiler will strip away all of the unused code so that the code can be as small as possible. Dart is really good at this, but if you include mirroring, suddenly Dart loses the ability to know what is used and what's not used by your application, because technically you could use everything. So that's one of the reasons why in Flutter we stopped using mirroring, why even though Dart had mirroring, the feature was disabled within Flutter. And so the alternative usually is code generation, but again, pros and cons. You probably are familiar with code generation, so I won't explain it, but generally the benefits are kind of like this flip over about reflection and mirroring is the generated code can be pretty fast, highly optimized, likely usually even more optimized than what you would write by hand, because it's kind of like you could write code that would be unreadable for humans because it's generated, so who cares about maintaining it? And it's highly flexible too, due to how code generation works. You could do some even more powerful things than what you could do with just mirroring. And tree shaking still works, of course, since it's just normal code but written by a tool instead. The problem is that now we are complexifying the way we write our code. So instead of just using Flutter run, for example, you now need to start build runner, for instance, or like have a script on the side, or like maybe separate CI steps to deploy your code. It becomes more complex. And at the same time, it increases build time because of it, because now you have 2 steps instead of just 1 step, and building code generation can be fairly slow if you're familiar with build runner. You have to analyze the whole code base. Not very efficient. And it's also quite advanced. I'm pretty sure the average Flutter developer wouldn't know how to write a code generator. You have to learn Analyzer, which is a bit more advanced than your typical Dart code. And so that's the idea behind macros, is that it was kind of like a third solution, kind of like in the middle. It was a bit simpler than code generation and more integrated with the Dart tooling. So like you wouldn't need a separate command to start it. It would automatically deal with code on its own. It also be a bit simpler than code generation. Your average Dart developer would have been able potentially to write code generation using macros, at least in theory. We probably won't know now, unfortunately. But then you might be wondering, why go through all of these extra steps and try to implement, try not to just solve the core problems behind macros directly. So like I mentioned before, that the main value behind macros was data classes and encoding, decoding. So why not just implement data classes in Dart? Like, it sounds obvious, right? The issue is those features are highly valuable, but are also quite a bit opinionated about how you do stuff. So like, if we reuse the previous toString example, say your toString of an object could be looking like this. Maybe you want it over multiple lines. Maybe you want to hide some given fields. Maybe you instead want to have the toString look like a JSON object. There are many different ways of rendering an object into a string. And the thing is, if the language ships something to render strings, then it will have to pick one solution, and all the other solutions are like, you have to figure it out on your own, and it wouldn't be a bit unfortunate. And so the idea is usually when the Dart team adds features, there is two layers where they add features. There's the language layer and the SDK layer. SDK layer is where you find all of your functionalities, like the Flutter SDK, where you get custom widgets, the Dart SDK, where you can use the future class, the stream class, stuff like that. Or like I/O, where you can read files and all. Technically, you can add new functions, you can delete existing ones. It's very flexible. Whereas the language is more about kind of like the rules of the language. Because kind of like, if you were to talk in English instead, that would be your vocabulary, grammar rules, stuff like that. Those tend to not change very often, and when you add new language rules, language features, it's very difficult to modify them in the future, because then it becomes a huge Perkins range. So what the team wants to do in general is push as much as possible to the SDK, or like maybe packages and stuff like that, so that people can build stuff on their own instead of having to maintain them in the language itself. And basically this difference was what macros were supposed to be. So instead of implementing toString, equal, and other features related to data classes and serialization inside the language, it was instead a tool to help people write those functionalities. So kind of like mirroring, like I explained before, but just solving the issues with mirroring and stuff. Not sure if you followed. If you have any question, of course, you can ask later. The thing is, now that macros are dead, what do we do? Then there are a few things that we can do from there. So first is we can try and find simpler ways to deal with macros, simpler solutions, because like I mentioned, the main reason why macros were cancelled is that they were too complex. So if we find a simpler solution, maybe that will land. Alternatively, not everything related to data classes and encoding, decoding is opinionated. There are some features that are fairly likely to land in Dart, and maybe you wouldn't have the full scope of data classes, but some part of it. And also, we could also improve about the, we could improve on how we currently do stuff at the moment. So like, for example, improving build runner or analyzer or other stuff. So in part here, about improving build runner, for those who care, is, of course, we do want to make it a lot faster. And for that, I would encourage you to visit the build runner repository. There is actually a discussion on the build runner repository with dev releases about performance improvements. And if you can try them, that would likely give them some feedback. See if, for example, your code now runs slower than before. They would likely be very interested in this. Also, build runner at the moment is kind of like something on its as a standalone tool. It's a bit inconvenient to use. You have to run build runner watch on your own, restart it if it somehow stops, because sometimes it stops. It's inconvenient. And so we could imagine a world where the IDE automatically starts build runner, or like when you do Flutter build, it automatically handles code generation, many different options. And also there are some possible alternative solutions to code generation, like not necessarily build runner specific. For example, one experiment I saw discussed by the team was instead of a command line to generate code, we could have your IDE itself do the code generation, as in, you know, when you open your IDE and you do a mistake, there is red squiggly underlines to highlight possible errors. So we could have the part responsible for those red squiggly underlines also do code generation. That's one thing that has been investigated. And there are many many small improvements, developer experience improvements that are highly beneficial, I would say. For example, here this one is a screenshot of an issue where basically, you know, when you use code generation, you kind of lose the go-to definition, code generation tend to generate new classes and stuff like that. And so when you go on the definition of that class, you don't go to the code you wrote, you go to the generated file instead, and that's a pain. Usually you want to go to your code instead of the old one. This issue is about offering ways for a code generator to tell the IDE where the go-to definition should go instead. Alternatively, there are a bunch of features that are discussed. Some of them are likely to land, some of them are less likely to land. Here, the first one is augmentation libraries. This one is pretty likely to land at this point, I would say. It's actively worked on, there are some experiments around it. The idea about augmentation libraries is, you know how when you use code generation today, you have to use something called part. You have to define a part and do myfile.g.dart, and then it generates myfile.g.dart, and it contains generated code. The thing is that generated code is just typical normal code, and when we do code generation, when we write a code generator, we tend to want to do stuff that typical generated code wouldn't allow, if that makes sense. Like, say, if you use Frizzed, typically Frizzed wants to inject some code inside your Dart class. And so the only way for Frizzed to do that at the moment is to ask you to add a mixin to your class. But you end up with like a weird underscore $person on your class. That's a bit odd. Same thing with the from JSON. You end up with underscore $person from JSON. It looks weird. I know it looks weird. It's all right, but it looks weird. The idea about augmentation is to add the necessary plumbing to enable code generation to just remove those $stuff. So you would remove the mixin, and the from JSON could just be abstract, and then the generated code would generate the implementation for that abstract constructor. And we could even go one step further with Frizzed in this scenario. We could even have it on the annotation, say it's erasable, and then Frizzed would generate the from JSON for you. A bit less code. So that's the idea of augmentation library. Yeah. The way it works is basically you now become able to split the implementation of a class into multiple parts. If you use C# before or stuff like that, you might be familiar with partial classes. That's related. So the idea is you define a class, and then you can augment a class, which maybe allow adding constructor, adding fields, other stuff. Another proposal, this one I'm not sure if it will land, but it's worth mentioning here, is addConst. Unfortunately, the text has been moved, so if you want to see the full proposal, you'll have to click on the issue to read about it. The short story about addConst is that it's some form of mirroring, but improved to remove the flaw around tree shaking and stuff. So a typical example here, again, syntax might change, or we may never have it, who knows, but for example, you could define a generic function and annotate the generic type with that addConst. And then using inside the function, using things like typeof and other, like we can see here, passing the generic, we can obtain metadata about that type. This looks very similar to the previous example related to mirroring we showed before, reflection. The thing is here, it's slightly different because the resolution of the code is done at compilation of the code rather than at runtime. So when you compile your application, basically the logic of this function is slightly rewritten by the compiler in a way that strips out all the metadata about the stuff. So in the end, when you ship your application, you only ship what you use. You never ship what you don't use. It's a bit similar to like constant objects versus final variables, if you're familiar with those. Yeah, so again, tree shaking tricks works, and performance is also, you could expect performance to be similar to just typical generated code. Another feature, which is, I think, fairly likely to land, is something called primary constructor. You can think of primary constructor as the nice part of data classes, like the syntax part, and not the equal or toString, but more about the single line way to define a class. The short story is here on the top, we have the usual way of defining a class, where you define a class, you list the properties, and you make a constructor to list the properties. And you have this duplicate where the age and name are duplicated. It's not super nice. The syntax with primary constructor at the moment seems to be as followed, where you could define a kind of like constructor named this, and at the same time as you define the parameters, you also happen to define the fields in your class, if that makes sense. So you remove the duplicate. There are a few variants of the syntax. Who knows what will land exactly, but that's the core idea. Another pretty cool one, in my opinion, is nested classes with a few variants. You might be familiar with cell classes, which is a feature that landed recently in Dart. So like if you use async loading or result objects, it can be very helpful. So the idea is, at the moment, you currently define single hierarchies like this in multiple classes, separate, and it can be not necessarily super obvious that they are related when you read the code, and there is a bit of boilerplate. And so there are a few proposals, for example, as followed, where you could define your result data. You could just define it within the result object as followed, and this then, if you wanted to use the data class, you would do result.data, if that makes sense, instead of just result data as a single name. Or alternatively, a more all-purpose way of using nested classes is just moving the class definition inside another class. The idea is this doesn't really change the implementation, it's more about organization. Here in this case, we know that the data and error classes are related to the result object. And it also solves issues like name conflicts, because like one issue with the result object, for example, is you wouldn't want to name your error case as error, because there is already an error class in Dart, whereas here you wouldn't have any conflict. Then another interesting one, although I'm not sure how likely it will be to land, but it's worth discussing, is something called static interfaces. The issue is more capable Dart objects. The idea is, you know how when you have a generate function, you cannot really instantiate the class associated to that generic. If you have just T, you cannot call the constructor on that T object. That's a bit inconvenient, and sometimes you might want to do that. And so this feature is designed to do exactly this sort of thing. So basically, you could define an interface like this. For example, this interface would represent classes with a constructor from JSON. And then when you define your decode function, which is the same as the previous one, when you specify your generic type, you could say it statically implements the previously defined interface, which then enables you to call constructors on the generic type. The next step would then be that when you define a class, you need to statically implement an interface. So here we implement the decodable and we specify the related constructor. And last but not least, we can then just use the decode function as expected. This avoids passing various callbacks and stuff. You might be wondering why not just do the old way of passing a closure or something like that. One good example is that, for example, if you use JSON serializable, you might have come across the generic argument factories functionality. Like when you want to decode a generic class, your from JSON into JSON functions tend to require a few extra parameters to decode those generic objects. But it's a bit inconvenient to use. And so with this new feature, we could simplify that. We could remove those extra parameters and just keep a simple from JSON, even for generic classes. Of course, the dollar stuff would be removed by different features. Right, so that's about it for the Dart feature side. But then you might be wondering, what about my different packages? Because of course, I tend to use code generation in quite a few of my packages. I like it, to be honest. What about freeze, for example? I would say freeze for now is fairly likely to stay relevant, at least in the short term. In the long term, I believe we're likely to have over time like things like primary constructors and a few other, and in those cases, it's quite possible that maybe JSON serializable will take over freezed because of those new features, because at that point we wouldn't need the unique freeze features. But for now, freeze is pretty much fine, I would say. And on that note, 3.0 release was made recently, which enables you to simplify the syntax a bit. It becomes less awkward, and if you don't like the factory constructors, you can just not use them anymore. For Riverpod, I unfortunately don't have a clear answer to give you right now. It will mostly depend on the future of Build Runner. I'm actively looking at how code generation evolves in Dart, but at the moment I know that code generation tends to be like 50-50. Half of the people don't mind using it, and half of the people hate using it. And so I don't like the idea of having half of the people hating code generation, and I also don't like the idea of having two ways of doing the same things. I think it's not healthy for the community. I think like whenever I add a new feature to Riverpod, I have to duplicate it somehow. I have to do it once for code generation, one for not code generation. That sounds great. So in the short term, one thing I'm investigating is find alternate ways to use providers and stuff like that, which would maybe not require code generation. I won't go in details about it. There is an issue pinned on the Riverpod repository, which you can look at. It details all the possible syntax changes. If we are lucky, if Builder becomes good in the future, or if a new alternative solves the issues, then we can maybe keep using code generation, because I still believe that the code generation syntax for Riverpod is better than whatever proposal we could come up with. It's just, I think overall I would prefer, if it comes down to not having a good code generation, I think my plan would be to probably stop promoting code generation and just unify the syntaxes to have just one, so that we can have better documentation, better features, better stuff like that. And for the long term, I still plan on shipping a few code generation-based packages. I have a bunch in mind. Even at Invertase, I'm working on some. I still think code generation is very relevant to Dart. There are a lot of things that we won't be able to do even with the features mentioned here. So it's not like it's going to be disappearing anytime soon, I would say. Yeah, I guess that's about it. So overall, I would say I've seen people asking, macros were cancelled. Does that mean Google is giving up on Flutter or Dart? Maybe they don't have the budget anymore. I would say no. I would say that instead, it's very impressive that the Dart team has been working on so much time on macros and also decided to cancel them. I think I would look at it a different way. I would look at it as how many languages would make such a, how to say, spend so much energy on trying to do something high quality, and then also once it's highly requested by the community, realize that it's not actually a good decision for the language and takes the blame and kill the feature, even though it's going to cause backlash, because of course many people were very disappointed in it. So in my opinion, it's very impressive. And the Dart team is definitely still working highly on solving those problems. There are discussions literally every day about augmentations and other features. So I'm not worried at all. I talked about a lot, so I think that's about it for me. I don't really have much to add. So thank you very much.
So time for QA. So raise your hands, please, if you have any question.
No, that was perfect. Yeah, of course. Usually it's the other way. There's one. So it's not the other way. I'm saved.
Thanks a lot, Remi, for an amazing presentation. Wondering, is there anything that Flutter devs can do to help show Google that the Dart team actually matters and kind of give them more support besides contributing to Flutter and Dart directly?
That's a good question. I'll have to think about it. I don't really have something to give you right now, but I'm sure any form of content is pretty fine. Be it just if you want to do bug fixes for Dart to help them, if you want to write a blog, if you want to do anything. Keeping the community alive is a big part of making the team happy, I would say. I probably didn't answer the question, but I don't think I can say anything else.
I guess I'm wondering, like, is a lot of this to help make the developer experience better, or will this allow like things to happen in Dart and Flutter that aren't really possible currently?
It's a bit of both. Maybe not static interfaces. Nested classes are nice. Technically, macros have been usually the team around code generation is not necessarily to add new feature, but to do the same thing in a nicer way. It generally tends to be about making it more maintainable, and maintainable code is usually better. But features like the add const, if it ever lands, it definitely empowers things quite a bit. Basically, all of the things I've discussed so far are kind of they simplify things, and usually packages are a balance between what feature do I want to solve, what problem do I want to solve, and how simple can I get it to be. And there are a lot of packages out there who were never published because someone worked on the solution and realized the solution sucked. And even though they could provide something to help with the feature, they never shipped it because the syntax wasn't great or something like that. And so usually those sort of features tend to increase the likeliness that we can have a nice syntax for those problems. So it could be that new packages will be made thanks to this.
Oh yeah, that makes sense, thanks.
Come on, one more, 3. Hey.
So what do you think about the performance improvement in the build runner? I guess one of the things that usually people in the community we are hearing is just the build runner is not quite where it should be. How do you see that? I guess you are so dependent on that too. So.
Yeah. Personally, I can see a lot of possible improvements on build runner. In case you don't know, the main reason why build runner is slow is not necessarily that generated code is slow. It's more about the way typical applications are structured make it that basically all the files are importing themselves. So like, or whenever you are inside a widget, you somehow are importing implicitly all the files in the project. It's not like files are fully independent. And so the issue is that generated files tend to also depend on other generated files. And the nasty consequence of that is that whenever you modify one generated code, build runner currently doesn't know if the other generated code are impacted by this change or not. And so if you modify one line, you suddenly have to regenerate every single generated code in your project. And that's why it's very inefficient. But at the same time, usually generated code doesn't care about the changes you just made. So basically, those performance we could significantly improve the performance of code generation if we were able to tell build runner, hey, I don't care about this specific change. You don't need to rebuild the generated code. That's one big factor of improvement. We could go from rebuilding 1,000 files on one line of change to just rebuilding a single file. That could be a pretty massive boost. At the same time, there are also some fairly significant optimizations currently performed on build runner. In the recent experiments, it shaved off like 50% of the computation time, which is pretty nice. When it takes 30 seconds, you win 50 seconds. You're quite happy. So yeah, there is a big factor of improvement. The question is more about whether we will get the full way there, or because usually it's a matter of how easy it will be for a code generator to implement their logic. Because one of the reasons, the first issue I mentioned about everything rebuilding every time, the reason it's this way, it's not that there is no way to make invalidation better. It's more that it would be a lot more error prone for code generators to do that, a lot more complex. And so it's a trade-off between making code generation simple and optimized. So we'll see where we land. But if I'm not happy with how build runner lands, I'll probably make at some point try to make my own code generator. I'm not sure if it will be good enough, but I'll likely try something. I have some ideas in mind. Thank you.
So I'd like to get your take on sort of this idea that like we could live with all these packages, right? Whenever I use like Riverpod, I'm gonna go use Freeze. I'm gonna go use, like all these things that sort of built up on the ecosystem. But does it make sense to just have a batteries included language where all these things just kind of are part of the language instead of fiddling with all this generated code and macros and so I guess, yeah, you want like Riverpod to be part of Dart or something?
Like I mentioned before, I think we need to make the difference between part of Dart and part of, because like, there are two ways we could implement Riverpod, for example. We could implement custom keywords in the language to define a provider. Mm-hmm. That's, for example, if you look at web, there are some UI frameworks which do that. I forgot the name, not Preact, but Svelte, I think. I think Svelte has its own syntax. Svelte. React has like JSX, stuff like that. We could imagine a world where widgets are done in a language-specific way. Or you could have them part of the SDK and just use them as usual. And then the thing is that the difference between the SDK and a package is actually very minor. It's just adding a dependency on your app. Technically, packages like Riverpod and stuff could be merged to either Dart or Flutter or something like that. The main issue, I would say, is more that those packages are quite opinionated and they tend to change fairly often. Like, I first wrote provider, we could have discussed about shipping provider inside Flutter. But then I wrote Riverpod, and we could discuss about having Riverpod inside Flutter, and then people use Block, people use Mobix, people use whatever. new ideas are appear every year, and if we keep making breaking changes in the framework, it would be kind of bad. So I think the idea of telling people make packages for those opinionated stuff makes sense, and the committee can naturally decide on what's good and what's bad.
Right. Those are all great reasons, you know, like it's, you know, but sometimes having an opinionated package is a good thing, you know, like.
Yeah.
And it's sort of like, again, the batteries included, you know, language, so you can kind of get started instead of having to, like, you know, flutter pup get 5, 20 things, you know.
Yeah, but I mean, I would say that Dart is already quite battery included. There is a lot of Sun already done by default. Like, especially when you consider Flutter, which comes with a lot of UI systems and stuff like that. It's sure we could include probably a few extra stuff in it, but there is already a lot done, I would say.
Thanks.
Thanks for the talk, was really interesting, and I'm going to check out the various issues later. What I want to ask is maybe a bit broader, not just code generation, but about Dart in general. If you could change something right now instead of Dart, anything literally, is there something annoying that you would like to change?
That's a good question. I already know what I want to change. There is this long-standing issue in Flutter that has been bothering me for a long, long time. You probably know about it indirectly. You know how in Riverpod we cannot use stateless widget. We have to use stateful consumer widget and stuff like that. It comes down to some issues in the way widgets work internally, some life cycles around inherited widgets. I would love to be able to change those such that we wouldn't need consumer widget and stuff, and we could just use the official build context. I've tried looking for a solution as a package for years. I've never found something that was fully working. Usually we can get like 19% there, but then the 10% remaining are like still broken. And I don't really want like memory leaks in the packages and stuff like that. Yeah, this would be a big for me, but I mean, that's just for Riverbot specifically. Yeah.
Yeah, I mean, that's already valid. I hear often that like some people that don't like Riverpod, it's usually because they have to switch all of the widgets to consumer, but makes sense. Thank you.
Any more question? Good.
No.
Okay, so thank you, Remi. So please give applause to him.